Students, in today's class we are discussing the numericals from your chapter Thermal Expansion of Solids. We have completed the theory in the class, but right now we are discussing some numericals based upon this chapter. Okay, and we have discussed first sum. So just discussing once again what we did in the first sum, then we will move to the second one. Okay, so what was our first sum? If you just go through the question, I'm just telling you the question in short. A copper rod's length is given and it is kept at some temperature, that is T1's value is 20 degrees C, and it has been heated to a temperature at 40 degrees C, and the linear expansion of copper is also provided in the question. That means these datas 1, 2, 3, 4, 4 datas are being provided in the question. What you have been asked to find out, what is the increase in length when it is heated to this temperature. Alright, so repeating once again, students, previously also discussed. For this you have to find out L2 minus L1. Okay, why? Because in the question it is asked what is the increase in length. Okay, don't only find out the value of L2. Clear? Find out L2 minus L1. Okay, so see the formula that I've used here. It's already written on top, alpha into L1 into T2 minus T1, and we have written the values given in the top devolution, in the devolution part, and we have come across this answer. Okay, now students, we will move to the next sum. I will just dictate the question of second one. See, a hole of diameter 0.06 meter is bored in an iron plate at the temperature of 25 degrees C. Okay, I will explain the question also. Find the temperature to which the plate must be heated in order that a ball of diameter 0.0605 meter just passes through the hole. Okay, and the coefficient of the linear expansion of the iron is provided, the data. Okay, so what is the question is telling us? A hole of diameter 0.06 has been bored. Okay, that means it has been excavated. I hope the term means the terms you are aware of these terms. These are purely English terms. Bored or excavated, whichever term you want to use. So a hole of diameter has been bored in an iron plate at the temperature 25 degrees C. Alright. Find the temperature, the next part of the question. Find the temperature to which the plate must be heated in order that the ball of the diameter just passes through the hole. Okay, that means we have bored a hole on the iron plate. Now what you have to find out, that to which temperature the plate must be heated so that a ball of given diameter can pass through it. Clear? Pass through it means can pass through the hole which has been bored in the iron plate. Okay, just the diagram I'm drawing, students. Suppose this is your iron plate. Okay, this is a hole that you have bored. Okay, so from that hole, how much temperature the plate has to be heated so that a ball of certain diameter, suppose this is your ball, okay, ball of certain diameter passes through that hole. This is our question. So let's start the solution. I think the question is clear to all. This is a 2D diagram that I have drawn, but it should be a 3D. Alright, I think you have come across the terms this 2D, 3D diagrams. Clear? So first of all, what we should do, okay, so the diameter of the hole, initially it was given, that is, you can check out from the question also, 0.06 meter, that is the diameter of the hole, and it is to be increased by how much, and the next value is also given, 0.0605 meters, isn't it? So that means now what you have to do, you have to find out that the diameter of the hole must obviously increase by how much. That you have to find out. That means you have to do the subtraction of this and this. Understood? What is this statement should be? This is the diameter of your ball. Was the diameter of the hole. So the diameter of the hole must be increased by how much? That means you have to do the subtraction. Got it? Which is equal to, do the subtraction, you will get 0.0005 meters. Clear? Okay. Now, in the question, you have been asked to find out the temperature. So, let us assume the temperature to be as T degree C. Okay. So, let's write the formula. We are using this formula only. That is your L2 minus L1 equals to L1 into alpha into T2 minus T1. Okay. So the increase of diameter means your L2 minus L1. Okay. Dimension is also length, and the increase in length you can write it as L2 minus L1. So let's do the calculation. Understood, students? This increase in diameter we are writing it as L2 minus L1. Clear? So what is the value of L1? L1's value is here this 0.06 into what is the alpha's value in the question given into 12 into 10 to the power minus 6 into T minus 25. Okay. As we have assumed the increased temperature to be as T degree C, you have written here. So your T2's value will be T and T1's value is already given in the question. Clear? So let me explain it once again till here.